This video is on box and whisker plots. A box and whisker plot is a visual display of a dataset, and to create a box and whisker plot we need 5 numbers, which we call the 5-number summary. That's the minimum, the quartile 1, medium, quartile 3 and maximum. Just got 2 examples to do to show you how to get these 5 numbers and then how to draw a box plot. First example, consider the dataset, and we've got the dataset there. First of all, we're going to construct the 5-number summary for the data. To do this, we're just going to go straight to the calculator, put the data in there and get the 5-number summary. Let's go over to that now. On the calculator in a spreadsheet, we'll just enter all the data in a column. As you can see, I have already done that here. From there then, we need to bring up the statistics. So we need to go to Menu, Statistics, Stat Calculations, and then just our one variable statistics like we've done previously. So X1, our list of data, so that is in column A, and our results are going to go into column B, which is perfect. Okay, and we have all the information. Now, if we just go down the list, you will see eventually we get to our 5-number summary in the order that we would like it. The minimum, quartile 1, medium, quartile 3, and maximum. There's our 5-number summary that we just found in the calculator. Part B, draw a box and whisker plot. To do this, we just need those 5 numbers. The first thing we're going to do is create a scale. It needs to go with the range of numbers we have in our 5-number summary. So here's my scale. Now we just need to plot the numbers. So this is how I do it. First of all, I start by plotting all the 5 numbers. So minimum is 1, quartile 1, 3.5, median 5, quartile 3, 6, and the maximum 11. So put all the 5 numbers on there as dots, and then draw a vertical line at each of those dots that I've just drawn. The middle 3 dots create my box, and then the outer 2 dots, my maximum and minimum, create the whiskers. With a box and whisker plot, just one thing when we're drawing it to make sure that we don't do is that we don't draw a line through the middle of the box, a horizontal line that would like join all the whiskers. That's not allowed. The horizontal line is to go only between the minimum or the maximum and the quartiles. So we've got to make sure the only line in our box is our median, which is a vertical line. Part C, find the range and the interquartile range. So the range really easily, maximum minus minimum. Go back to our 5-number summary. Our maximum is 11, our minimum is 1, so therefore our range would be 10. And our interquartile range, remember, is quartile 3 minus quartile 1. Our quartile 3 is 6, our quartile 1 is 3.5, so our interquartile range then would be 2.5. Now part D, find the percentage of data values less than 3.5. Another really important thing with our box and whisker plots to note is that each section of a box and whisker plot represents 25% of the data. So our box and whisker plot is split into 4 sections. We have 1, 2, 3, 4. It's 4 sections, and now each of these sections is 25% of the total data. It doesn't matter how big one section looks compared to another section, each section represents 25%. The interquartile range, which is the whole box there, that is your interquartile range, represents 50% of the data as well. These are just a few little pointers that can help answer a question. So for this part D here, find the percentage of data values less than 3.5. 3.5 is our quartile 1. So less than 3.5, we are wanting to look at everything below our quartile 1. I've just shaded it in light blue there. Now, as we just said before, each section of this box and whisker plot represents 25%, which means less than quartile 1, that less than 3.5 would be 25% of the data values. Next example, an office worker has a choice of travelling to work by car or bus. He wants to know which method of transport is the quickest and which is more reliable. He recorded the following travel times from recent journeys using both methods. The results below are shown in minutes in ascending order. we want to draw a parallel box plot for the data sets. What a parallel box plot is where we have two box plots that are drawn on the same scale. First thing we need for both sets of data are the 5-number summary. So for the car, we need our minimum, quartile 1, median, quartile 3, and maximum. And we need that for both the car and for the bus. To do that, we're going to go back to our calculators and to get the 5-number summaries. Here, I've put both sets of data into 2 columns. So the car is in the first column, bus is in the second column. You can work out your summaries separately, but there is a way to actually get both 5-number summaries in one step rather than having to do it separately. Once you've got your data in, if you go to Menu, Statistics, Stat Calculations, this time though we have 2 variables. We have car and bus, which are 2 variables, which means we can go to the 2 variable statistics instead. Then, Xlist, where is our first variable? That is in column A. Our Y-list, our second variable, is in column B, so we just put B and then our square brackets. And then our results are going to go to column C, absolutely fine, and then OK. What we see now in our data is that we have our X information first. We've got the mean of our X, the sum of all the X's, etc. Then we have our mean of the Y, so the mean of the second lot of data. So we actually get all the data for both variables in one section. And as we keep on scrolling down, we then see that we end up with a 5-number summary here. And it says min X, Q1X, so that's for our first column, our first variable for the X. So here's our 5-number summary for the cars. And then if we go down just underneath this, we then have the 5-number summary for the Y, which in our situation was the bus. Now we've got both 5-number summaries, we can draw the parallel box plot. To start with, we need to make our scale, and we need to go from the minimum to the maximum and the smallest and the largest out of both. So in this situation, our car minimum is the smallest at 13, and also it's also got the biggest maximum at 43. So we need to have our scale going between those 2 values. Once we've got our scale, we then get to draw our box plots. So I'm going to start with the car first. I'm going to plot all the 5 points and then create the box plot. So there's the box plot for the car, and then we're going to do the same for the bus. But with the bus one, we're going to draw it above. So you can do them in either order, one above, one below, as long as they're obviously not overlapping. Now you see this one is a bit more squished together, which is absolutely fine. It's why you sometimes have to be mindful of your scale to make sure that you still can draw the box plot. And then we have a parallel box plot. So you can see there we have 2 box plots on the same scale. And this can help us then be able to answer questions about the data because we can see them side by side. So part B, we then want to determine which method of transport do we think is quicker and more reliable. Quicker, what we would be saying here would be the bus, even though the car does have the quickest time at 13 and 14, which are less than the bus. All the other times, if we look at the data, all the other times for the bus are quicker. There's only the 13 and 14 that are less. Overall, the bus does have quicker times. We can also see that from the box and whisker plot as majority of the data is here. That's 75% of the data is there, and where 75% of the data for the car covers a much larger range, which means we can say that the bus is generally quicker. And then we want to know which one is more reliable. Once again, we will be saying the bus in this situation because the spread of the data, the bus times the spread, is much smaller than the spread of the car, which goes between 13 and 43, where the bus only goes between 16 and 30, which means it's more reliable because the times are much closer together. So I'm just going to say that the bus has a smaller spread, therefore it's more reliable. And that is box and whisker plots.